Good afternoon, everybody, and welcome. We are so excited to have you join us today for our final 2024 Wisconsin Farmers Union Fall Lunch and Learn webinar. My name is Kirsten Slaughter, and I am the Membership Engagement Director for Wisconsin Farmers Union. And I'm so pleased to have you on our call today as we talk about ethanol and preparation for our facilitated discussion at Groundswell, the pre-convention portion of the Wisconsin Farmers Union Annual State Convention, December 13th through 15th. Wisconsin Farmers Union is a membership-run organization whose members set the policy and educational initiatives that we then advocate for to improve the quality of life for family farmers, rural communities, and all people. If you are not already a member of Wisconsin Farmers Union, we invite you to join us today in our work. Today, we will be hearing 4 different flash presentations around the growing and production of ethanol and its policy, farmer, land use, and economic implications. The flash talks will provide you with information to prepare for engaging in a dialogue at Groundswell on December 13th, where during the dialogue, you'll practice having respectful conversations with others who may have different views. It will not be about persuading others to think differently or to make any kind of decisions together. Instead, the dialogue will give you the opportunity to step into curiosity, check assumptions, and ask questions of inquiry. I'm going to share a quick slide right now to talk about some of the questions that we will be asking during Groundswell. In preparation for Groundswell, please use the questions on this slide to engage with the flash talks. You may want to take notes of your response, and I'll give folks just a second to kind of glance at those questions. We'll share them again at the end so that you have a preview of them before our Groundswell pre-convention. Today, we will hear from Ann Steckel, the Senior Advisor for the National Farmers Union, Geoff Cooper, President and CEO of the Renewable Fuels Association, Tyler Lark, a scientist at the University of Wisconsin-Madison's Center for Sustainability and the Global Environment, and Andrew Stevens, an Assistant Professor of Agriculture and Applied Economics at the University of Wisconsin-Madison. We are planning on answering questions for all 4 panelists at the end of the presentation. So you can add those to the chat or the Q&A button during the presentations, and we'll gather those to ask at the end. And at this time, I will turn it over to Ann. Thank you.
Thanks, Kirsten. And thanks, Tara, for putting this together. Really appreciate it. The whole team at Wisconsin Farmers Union, appreciate all your work. So we thought it would be helpful as we're facilitating this discussion to just do some level setting on from a high level perspective of what the National Farmers Union policy is on ethanol. And you can actually switch it to the next slide. Thanks. Just so we're kind of all on the same page. As everybody knows, we're a grassroots organization and our members set our policy, and then we all get the chance to gather together. This year we'll be gathering in Oklahoma City to review our policy as we do every year. So just going to run through quickly what NFU's longstanding policy on ethanol has been, so everyone kind of knows what we've been operating under. Clearly, we've been doing a lot of work both on the legislative and regulatory front in DC, and all of the states have done their own respective work in this arena as well. And then I will keep my comments pretty tight, and then I really look forward to hearing everyone else's comments and answering any questions that people may have from the NFU's perspective, or listening to the other questions that may come up for our technical experts that are on the call today. So again, thanks for putting this together. So let me just quickly review and give an overview of ethanol in NFU. We've had a long-standing policy in support of ethanol. We devote a considerable amount of time from our lobbying team and our advocacy team to supporting ethanol on the federal level. And we do so for a variety of reasons, of which I've outlined here on our slide. I mean, clearly, from our farmers' perspective, we feel like it does provide additional market opportunity for farmers, and it does help revitalize rural America through jobs. And then health benefits are also something that has been, long talked about, with cleaner air, obviously reducing carbon, vehicle emissions. Something that's been, when we've passed the RFS in '05 and then revised it in '07 was the genesis of that was really focused around increasing energy independence. And I think we're certainly continuing to see that as a main thrust of why domestic ethanol program is very helpful to us and why a renewable fuel standard has also been very helpful to us. Certainly, this is a program that has benefited all consumers really through lowering fuel prices to the pump for consumers. And we see that particularly as we talk about raising the amount of the volume of ethanol that's in our gasoline supply. Base is E10, obviously E15 can be done year round in 8 states, working to get that passed year round for every state. And then as we look towards higher level blends as well. And then, of course, something that we find a lot of commonality with when we talk to OEMs or auto manufacturers is really the engine performance, which is something that they're looking for. And we can achieve that through using higher level blends through octane, which is also something that we're seeing requested from the consumer. And the next slide would be great. Again, so just some of the big picture policy items. These are not new to any of us. They're in our policy book. We review them every year. We've got about 2 pages full of policies that do support ethanol, but just to review those for folks, we do support higher level blends of ethanol. Again, I was mentioning moving to E15 and then gradually moving even higher to mid and higher level blends of ethanol like E20, E30, which is again when you really start to see benefits of the octane, higher level benefits of octane, and lower air toxins as well. We're doing that through breaking down regulatory and legislative barriers, as I mentioned, through our advocacy efforts. Some of our other policies we support are research and development and investment in biofuels, continuing to support strong science, continuing to support the technology and the evolution of it, and really working to drive down our carbon emissions. We also support tax credits, flex fuel vehicles, and then of course, as I mentioned before, and something that we are all very familiar with is the Renewable Fuel Standard, which has been a very successful policy in diversifying our transportation fuel supply. And then finally, another issue that we've talked a lot about and dealt with a lot, and an issue that actually went to the Supreme Court was over small refinery exemptions. And we do oppose improper use of small refinery exemptions. So just a quick review from NFU's perspective on where we've been with ethanol issues. I can go to the next slide. So with that, I will turn it back to Tara and team. I'm happy to take questions at the end, or obviously everybody knows my contact info. You can reach out to me afterwards as well. I'd welcome any discussion.
Thank you, Anne. And now I will turn it over to Geoff.
All right. Well, thank you, Kirsten, and good afternoon, everyone. I appreciate the invitation for this discussion this afternoon. I was asked to give sort of an overview and update on what's happening in the ethanol industry today, what the industry looks like. So I'm going to try to share my slides and just kind of walk through some of the issues and priorities that we are working with as an industry. So I want to start with, if I can. Just a snapshot of what the industry looks like today. Today, we have nearly 200 ethanol plants across the U.S. 31 states now have ethanol facilities. Of course, Wisconsin is a big ethanol producer, ranks number 8 in the U.S. There are 9 ethanol facilities in the state of Wisconsin, producing about 700 million gallons of ethanol annually, consuming about 250 million bushels of corn. But nationwide, the industry has grown to a capacity of almost 18 billion gallons. The industry has not operated at full capacity, but has come close. We have proven the ability to produce about 17 billion gallons on an annualized basis. That run rate doesn't last all year, but we do see during those periods of high demand the industry ramping up to that rate of output. Obviously, most of the ethanol plants are where most of the corn is. That does remain our top feedstock. About 99% of ethanol produced in the U.S. Comes from corn. There's a little bit that comes from grain sorghum, and then a little bit that comes from other feedstocks, wastes, and residues from different processing facilities. But one of the things I want to point out here is we do have a very well-established infrastructure for producing ethanol in the U.S., not just the 199 facilities that you see on this map, but also the transportation infrastructure that exists to get this product from where it is produced to where the demand centers are, which is typically where the population is along the coasts. Again, here's a quick snapshot of the industry's output and what we've been producing the last several years. In 2023, we saw right around 15.5 billion gallons of ethanol produced. We've sort of been between 15 and 16 billion gallons of annual production the last 7 or 8 years. Of course, you see the big drop in 2020. That was because of COVID and the demand destruction that we saw in the spring of 2020 and the summer of 2020 as folks were working from home and schools were, students were at home. But we've seen a nice recovery since 2020. We're on pace to produce somewhere around 16 billion gallons this year. So we'll be very near that record amount that we produced in 2019. 16.1 was the all-time record, but we'll be close to that. That means we're consuming about 5.5 billion bushels of corn this year. That's about 35% of corn demand. So a huge demand segment when it comes to the corn market, right up there with livestock feed, which is also in that 5.5, 5.7 billion bushel range. But again, as I'm going to show on some of the next slides, we're not just producing ethanol at those 199 facilities. We're also producing a lot of animal feed, very high protein animal feed, about 35 million metric tons last year, somewhere around that same amount this year. But also distillers corn oil, that the fat, the germ that's in that corn kernel, we're removing the oil. And much of that today is either going into the poultry feed market or into renewable diesel and biodiesel as a feedstock for those products. Here's just a very basic schematic of the ethanol process. I'm not going to go through every step here, but it's if you're familiar with how alcohol is made via fermentation and distillation, that's what we're doing at an ethanol facility on a very high-tech, advanced scale, large scale. But again, what I really want to point out here is kind of in the middle and left-hand side of the chart. That we don't just produce ethanol at these facilities. Through that distillation process, we end up with a lot of animal feed and distillers corn oil that goes into those animal feed and alternative fuel marketplace. Again, looking at what happens when you put a 56-pound bushel of corn into the ethanol facility, this is what you get back out. You get about 2.9 gallons of denatured fuel ethanol, about 15 pounds of that distiller's grains animal feed, almost a pound of that distiller's corn oil that is then going into biodiesel, renewable diesel, and animal feed. And we're also getting as a co-product of fermentation CO2. When you ferment starch into ethanol, one of the byproducts of that chemical reaction is the release of CO2. Today, about a quarter of the industry is capturing that CO2, including many of the facilities there in Wisconsin, and taking that CO2 and selling it into a number of different industrial markets. There is high demand for CO2 for things like carbonating beverages, producing dry ice, flash freezing. There's medical applications. There's wastewater treatment applications. During COVID, we had very high demand for CO2 to help refrigerate vaccines that were being shipped all over the country. So that's another product that comes out of the ethanol industry that I think is often overlooked. And sort of referenced how ethanol is being used in the marketplace today. The predominant use of ethanol in the U.S. is in a 10% ethanol blend we call E10. There is some E15, 15% blends that are making their way into the marketplace. Like Ann, our organization very strongly supports and advocates for growth in those higher level blends. There are about 3,500 stations that are selling E15 today. You might find it at many of the quick trip stations there in Wisconsin, a very popular fuel. And then there are flex fuels, the E85 fuels that are made for flex fuel vehicles. Ann mentioned E20 and E30. Those fuels are not broadly available in the market today, but we are advocating for the introduction of those fuels because, as Ann mentioned, that is the highest, best use of ethanol. That's where the automakers get the full benefit of the octane value of ethanol and the carbon reduction value. Here's just kind of hammering home the point that ethanol saves you money. Ethanol blends are the lowest cost fuels available at the pump. And in almost every case, the lowest priced fuel at any pump you pull up to is going to be the fuel that has the most ethanol in it. So I think this came from a Casey station, pretty typical of what we see across the marketplace. If you're buying E0, gasoline with no ethanol in it, you're paying an arm and a leg for it. If you're buying E15 or E85, those blends with more ethanol, you're going to be getting that more significant discount. Ethanol reduces greenhouse gas emissions. This is one of the things that Ann mentioned briefly. There's been a number of studies done by the Department of Energy, folks at Harvard University, MIT, Tufts University, California Air Resources Board, Oregon Department of Environmental Quality, EPA, Purdue University, University of Illinois. I could go on and on and on. Those studies typically find that average corn-based ethanol reduces greenhouse gas emissions by somewhere on the order of 40 to 50% compared to gasoline, and that does include hypothetical or potential land use changes that could occur from expansion of the system. We're on pace to get that reduction down to about 70% on average by 2030 as new technologies are coming down the pike. And we believe, in fact, our membership has pledged to reach carbon neutrality, net zero emissions ethanol by 2050 or sooner, with the adoption of carbon capture and sequestration and other technologies. And also mentioned this, ethanol has other air quality benefits, not just greenhouse gas emissions. Using ethanol reduces particulate matter, carbon monoxide, hydrocarbon gas emissions, nitrogen oxides. These are the pollutants that cause smog and air quality problems and health problems, asthma, lung disease, heart disease, many other illnesses. So, very recently, the University of California, Riverside looked at what happens when you move from 10% blends to 15% blends. And these are the reductions they found after testing 20 vehicles: 18% PM reduction, 17% carbon monoxide, reduction in hydrocarbon gases and NOx emissions as well. So again, the more ethanol you're using, the better benefit you're going to get. I want to finish with just a couple quick slides on highlighting some of the efficiency that we're seeing in agriculture and in the ethanol industry, and really help correct the record, I think, on some of the myths and misinformation that's out there about the effects of ethanol expansion over the past 20 years. And one of those is around land use. And I think when you look at the U.S. Department of Agriculture's data, they do an ag census every 5 years, but every year they are collecting data on land use. And what that data shows is, in the U.S., we are cultivating fewer and fewer acres in our ag sector each and every year. That trend has continued. It has not been interrupted by the emergence of renewable fuels. You could argue that, well, would agricultural land use have fallen more dramatically without ethanol? Yeah, it would have. I think that's safe to assume that. I think it's safe, that's probably a safe assumption. So in our view, the effect of ethanol has not been to cause massive cropland expansion like some have predicted. It's been to keep farmers on the farm. It's been to keep cropland in production. It's been to keep agriculture moving ahead in a more profitable way. I'm going to skip through some of these because I know I'm running short on time. This one just shows the orange line, which is plotted against the right-hand axis. There is corn production dating back to 1920. And you can see that we've seen an enormous increase in the production of corn in the U.S. a 600% increase. In fact, we've gone from about 2 billion bushels annually up to 15 billion bushels. We've had 15 billion bushel crops in the last 4 years. And at the same time, we're not expanding the amount of land that is needed to produce that crop. That's what the blue line shows that's plotted against that left-hand axis. We're actually planting and harvesting a lot less corn acreage today than we did back in the 20s and 30s. And that's because we're getting more corn per acre, obviously. A record corn yield this year, 183 bushels per acre. That's up from around 20 or 30 bushels per acre 100 years ago. So again, dramatic increases in the productivity and efficiency of the American farmer. And that's why we're able to take 5.5 billion bushels and send it into the renewable fuel industry without affecting other markets and uses for corn. And that's what this chart shows. The orange there is basically how much corn is available for food and feed use and other uses. And the green is how much is used for ethanol each year. And what you see there is in the emergence of the ethanol industry over the past 20 years, we have not taken away, we have not removed or diverted corn from uses in other segments, other demand segments, especially in the food, feed, and livestock industry, especially when you factor in that contribution of the distillers' grains from ethanol facilities. Last chart I have is just, we also hear this myth out there that, well, we're growing more corn, and so there's more fertilizer and more runoff, and that's leading to hypoxia, and it's all in the Gulf of Mexico, and that's all because of ethanol. The data it just doesn't support that notion. Those orange bars are the size of the hypoxic zone in the Gulf of Mexico. The green line is corn production. You can see there's no correlation. You don't have to be a statistician to recognize that there is no clear relationship between corn planted and the size of the hypoxic zone in the Gulf of Mexico. There are a lot of other factors that determine the incidence of hypoxia in the Gulf of Mexico. Certainly runoff is one of those, but it's not the driving factor, and corn production certainly is not a driving factor in the occurrence of hypoxia in the Gulf of Mexico. So I wanted to just walk through some of those myths and misinformation that's out there and provide our response to that. But I will leave you with this. I didn't really get into our policy priorities because I knew Ann was going to do that. Ours align very well with the National Farmers Union. I think all of those bullet points that she showed are on our list of priorities as well. But at the end of the day, we see an enormously bright future for ethanol. We see continued growth because of its properties, because it's renewable, because it's a sustainable fuel. It's got that high octane value. It's reducing carbon emissions. And so we're very excited about what the future holds for the U.S. ethanol industry. And I certainly look forward to the rest of the conversation and your questions today. Thank you.
Thank you, Geoff. And now I'd like to turn it over to Tyler.
See some slides?
Yes, we can.
Great. All right, so I followed Geoff, and I was asked to try to talk about some of the considerations around land use and environmental impacts that people might want to think about. But more broadly, I'm really excited to be here. Really fun to be able to connect with Wisconsin Farmers Union. I'm from Wisconsin, grew up in northeast part of the state. A scientist here at the University of Wisconsin, and our team looks at US-wide agriculture and land use. And so we look at things like continued expansion of urban areas and sprawl and how it keeps eating up our best and most productive farmlands. We look for opportunities for conservation agriculture and regenerative practices. And then things like the shifting between pasture areas and CRP and grasslands and row crops, things like corn and soy. And it's that last topic that I would say for the last, I don't know, decade or decade and a half that we'd always get asked about. People would be like, how much of this shift of, between pasture and corn is due to biofuels or ethanol in particular? And we never had a good answer. It's a really, really hard question. It's so challenging. There's so many different ways to look at the data. But eventually about 5-6 years ago, we had the opportunity and said, what, if we're going to go out and answer this, what's the best guess? So what's the best we could do? So we assembled a team of agronomists and economists and agricultural geographers and said, can we tease out a little bit of just this interaction between ethanol and land use and what that might mean to kind of add that into the big picture? And so that's what we tried to do. That's what I'm going to share a little bit of the insights from that and try to relate it just more broadly to the overall piece of the puzzle. And so we heard a little bit of background about the Renewable Fuel Standard. This is just the big policy, and in some of our research, we've kind of tried to look at the policy, but it's indicative, I think, of just overall corn ethanol more broadly. And there's really been lots of unknowns about how did the U.S. respond to ethanol policy and the Renewable Fuel Standard, and what does that mean for the environment? And it's challenging because you have to estimate and figure that out. Like, what would have happened without this growth? And Geoff alluded to that a little bit. Like, we're losing cropland in many areas, and maybe we would have lost more cropland without these support and increased prices from ethanol. I think if we summed it all up, it makes sense, and this is kind of the takeaway that folks can think about when they think about, okay, how does ethanol policy or production or use kind of have an influence on land use and the environment? So if you have, can folks see my pointer? Probably not. That's okay. You don't need to. But on the left side, you've got, if you have a policy or whatever it is, increased demand for corn ethanol, a greater use of a product like corn, that's going to increase crop prices, right? And potentially depending where you sit, that could be a really good thing. So you have increased demand for corn ethanol, increased crop prices, and in general on the landscape, you can meet that increase through two pathways of land use change. You can either plant more corn in the existing rotations, which we see, or bring more areas like pasture or CRP back into production. And both of those would have associated impacts in environment that can be estimated, and that's in general kind of that interaction that we think about from the land use side of how ethanol might play out on the landscape. We tried to get into estimating some of the numbers. I think the numbers aren't as important as just the big picture concept that people are kind of curious and interested in learning more about to help inform their position on this. But as I said, a policy that supports ethanol, we estimated it increased demand by about 5.5 billion gallons a year, which it's about a third of the total production of ethanol right now, and really just probably accelerated when that happened, right? And just got there maybe a little bit faster. And that acceleration, we estimated, was increased corn prices by about 30%. So that's one number. There's a range of estimates of what that might have done, from 2% to 40% or something. But in general, increased demand for corn, going to be good for corn prices. And then kind of interestingly, it also increases the prices of other crops. So soybeans and wheat, we think get increased a little bit as well, but to a lesser extent. And that makes sense, right? Corn prices go up. We plant a little bit more of our cropland to corn. We plant a little bit less to soy and wheat. Supply of those two goes down, so the prices go up a little bit to match that. Again, nothing surprising here. Nothing probably that anyone would disagree with. And then what does that play out on the landscape? Well, it just higher corn prices. We've seen greater amounts of corn on existing cropland. So both in the form of more continuous corn, just doing back-to-back corn within rotations. In Wisconsin, really not even that much change. Most of the shifts are more on the margin. So when you move out to like the Dakotas and things, that's where we'll see a little bit more of a response in changing crop rotations to overall increase in ethanol and changing cropland area as well. And so this is the shift in cropland area, how much more land goes towards row crops that might have otherwise been, say, in pasture or in the CRP program, or in a perennial forage or something like alfalfa or hay. And so we see a little bit, most of the increase of row crops is in, again, the Dakotas. Wisconsin really saw almost no change. The one change we did see is less, it's here termed grassland restoration, but essentially that's like enrollment into the CRP. So maybe you have a neighbor who had some land that they were farming and was thinking, yeah, I'm going to sign up for CRP, that's some land I'm thinking about taking out production. And with the higher prices, over the last decade or so induced by the RFS, maybe they didn't enroll into that program or didn't shift into pasture. That's really the main impact that we saw in Wisconsin, at least. the number one change. All these shifts, just in amount of corn production and row crop production relative to pasture, CRP, or perennial systems, have a potential to influence environmental outcomes. Obviously, everyone here probably knows even better than I, right, that corn is incredibly productive, right? There's a reason corn is king. It has incredible yields, but it's also relatively intensive and requires a lot of nutrient inputs, right? And so if you increase corn production, we've seen an increase in associated nitrogen application and phosphorus application and some soil erosion. And obviously that varies a lot given the types of practices, and a lot of conservation practices can mitigate this, but on average, with more corn on the landscape, compare relative to, say, a perennial system or pasture, you'll see a little bit more of these nutrients applied, and in general, it's a little bit leakier system than some other cropping systems, so maybe a little bit more into the environment. So that's, if you have to balance the trade-offs of the higher prices and the increased support, I guess these are the flip side of the coin of what comes with it. This is basically saying that same thing and just looked at how much these environmental outcomes have changed in general. You know, the increased corn and cropland area from the ethanol policy has increased some of these environmental outcomes by 3 to 8%, so about 5% across cropland. Everyone probably has a different perspective on what that means, if it's big or small, and you know, how that balances across some of the other trade-offs of ethanol. The one piece that folks have looked at a lot and then tried to get better understanding is what this means for the climate or the net greenhouse gas benefits. And as Geoff alluded to, lots of uncertainty around this, lots of debate, lots of different numbers. Some folks saying, you know, ethanol is way better. Some folks saying, oh, it's not really clear. I think the one thing that the science community and everyone would agree on all sides is that, you know, if you just took a gallon of ethanol and a gallon of gasoline and on a per energy basis, you know, burning that ethanol is cleaner and has fewer emissions, right? That's, I think, very well established. Most of the discussion and debate on this does come around this land use change component. And so if you factor in land use change, or how much land use has occurred and what practices are used, that's where then there's a little bit more uncertainty, and how much does that affect the benefits that ethanol would otherwise provide. And so, yeah, that's kind of the potential trade-off. So putting that into takeaways, what folks think about is, you know, if you increase corn ethanol, good for prices of corn, also increases prices of other crops, but not as much, really increases corn the most. Those higher corn prices will, you know, just as you would expect, you know, we respond and we respond to that call and plant more continuous corn, fewer kind of rotations with other crops, and also see less CRP and less pasture on the landscape. And then in general, you know, if you have a lot of those land use changes where you're converting, those can have a potential to have negative, you know, impacts on carbon emissions and other environmental outcomes. So those are things that we want to weigh against some of the other benefits of corn ethanol. And that's all I got. Excited for questions and Q&A, and yeah, happy to go from there. Thanks so much for your time.
Thank you, Tyler. And now we'll turn it over to Andrew.
Well, thank you very much. It's a pleasure being here with great other panelists. I'll try not to repeat too much of what's been said and leave plenty of time for questions. My role is to talk a little bit about the economics of this. Tyler has really set things up well. But I want to start with sort of our Econ 101 approach to why federal policy on ethanol would have an effect on corn prices and production decisions. And so if we think about there being some market for corn, where on the y-axis here we have the price of corn, on the x-axis we have the quantity of corn produced. There's some supply curve, right? Farmers have expectations about the price that they're able to earn for what they grow. And the higher the price for a crop, the more likely they are to produce that crop. And then there's some demand for corn, whether it's demand from animal feed or you know, direct human use or exports or whatever it is. that the lower price of something, the more will be consumed, and vice versa. And so the intersection of supply and demand helps pin down both what the market price for a good is and how much of it gets produced. And so we can think about the renewable fuel standard as shifting the demand curve, basically saying for any price of corn, there's sort of a guaranteed extra demand to produce ethanol that will push that entire demand curve to the right. And what that does is it establishes a new equilibrium price and quantity. So if that's all that happens, if the renewable fuel standard happens in a vacuum, we would expect more corn to get produced and for all corn to sell for a higher price. And that's sort of the basic Econ 101 explanation of why we think that federal ethanol policy is related to some of these corn prices, land use, outcomes, and things that we care about. So with that sort of down and dirty theoretical baseline, let's talk about what the economics literature has sort of estimated as this big picture what's going on. So Tyler, really covered some of this in general well. I want to highlight two papers that I think are helpful here to think about. So the first is this very influential paper by Roberts and Schlenker in 2013 in one of the most influential journals in all of economics. Their big question was trying to understand sort of what the relationship between prices and supply in agriculture is. And their big takeaway was that if we look at the ethanol mandate, the renewable fuel standard, that policy change had an impact of increasing food prices globally by about 30% and increasing world production area of commodities by about 2%. Now, there's a lot of caveats to those numbers, and if you think that there are a lot of byproducts of the ethanol refining process that could be used for animal feed, that 30% comes down a little bit. But this sort of gives that ballpark number of 30% that Tyler mentioned earlier. And then a couple of years later in the journal Food Policy, several authors did a meta-analysis of 29 studies that were asking very comparable questions and sort of saying, what's the relationship between ethanol demand and corn prices? And you look at all of this evidence together, and they're saying an additional 1 billion gallons of corn ethanol demand. If we think about what if there was some hypothetical policy that increased ethanol demand by 1 billion gallons, the average effect on corn prices would be about 2 to 3%. So that's helpful to think through sort of what the causal impacts of ethanol demand on these market equilibrium prices might look like. And so I want to sort of situate what Tyler was talking about in the context of this, which is ethanol policy has this aggregate effect. Ethanol demand contributes to aggregate demand for corn. That aggregate demand is what helps set prices and expected prices. And that is sort of the elephant in the room that influences producer behavior and land use decisions. I think this literature has done a good job of giving us some reasonable numbers. One thing that I think is interesting to help think through is how that ethanol demand is expressed and sort of the geography of some of those effects. So some research that I've done has looked specifically at the question of how the placement of ethanol refineries on the landscape affects local agricultural land use. And so this is asking less about the aggregate story of what ethanol demand has done to prices, but asking more about how the built infrastructure of the ethanol industry has contributed to these more local land use patterns. So just to, I think we've seen versions of this graph before. U.S. fuel ethanol production has increased, driven by the renewable fuel standard. And to accomplish that, we've seen an increase in the number of corn-fed ethanol refineries. The data in this project are a little old, so Geoff's data is certainly more up to date. But we're going to capture most of this big ramp up in processing capacity in the late aughts and early 2010s. I want to build an economic intuition here I'm speaking to the Wisconsin Farmers Union, so I think this is going to be pretty straightforward. If we think about, a farm that's in the Corn Belt producing corn and soybeans and is selling to the market, we think, there's transportation infrastructure, there's railroads or rivers, and there are grain elevators on the landscape. And so a farmer who's producing corn and soybeans is probably going to ship those corn and soybeans to the nearest elevator, keep those transportation costs as low as possible, and sell at the market price, or maybe you're in the forwards market, or something like that, but you're selling to this nearby elevator. If a corn ethanol refinery comes in, but it's further away than your closest elevator, you're probably still going to sell your corn and your soybeans to that nearest elevator. Why pay more to transport your corn further to sell it at the refinery, right? But if we think about an ethanol refinery coming in closer, then suddenly we might expect that corn to peel off from the soybeans, right? That you can spend less money to transport your corn to that nearby ethanol refinery, but you can't bring your soybeans there because the ethanol refineries don't use soybeans as a feedstock. And so what this can do is throw a wedge in between the relative prices or the relative profitability of these two crops for that farmer. And so I'll skip right to the graph here. That sort of theoretical model predicts two things. The first is that if I'm a field on the landscape and a new ethanol refinery comes in and is built, and it's further than the distance to my nearest grain elevator, my probability of growing corn, which I'm measuring on the y-axis here, is flat, right? That ethanol refinery isn't necessarily going to have a direct impact on my field likelihood of being planted to corn. But that if that new ethanol refinery is built close to this field, a field is close to that ethanol refinery, as that field is closer and closer to that nearest refinery, the probability of growing corn increases because that transportation cost of corn is decreasing relative to soybeans or something else that's grown. And so this is sort of the theoretical prediction of this transportation cost model, and we can actually test this by looking at some data. Geoff has a great map of where all the ethanol refineries are today. This is where they were in 2002. And if we think about this to 2014, what we see is really this increase in density in the Corn Belt, more so than, sort of moving outwards from the center. We're going to look at land use using satellite data. So this image is showing all the red dots are the ethanol refineries in 2014. The 4 states we're using are Nebraska, Iowa, Illinois, and Indiana. And what you see here is satellite data from the cropland data layer that's looking from space to see what's being grown on the ground at a 30 meter by 30 meter resolution, which is quite fine. So to combine those satellite data and turn them into fields, we use a unit of analysis from the USDA called the Common Land Unit, and we basically layer these two data sets on top of each other and look at each field and say, according to the satellite data, what crop is being grown on that field each year. And we use those data to sort of say, for a particular field over time, how is it being managed? I want to sort of connect the dots here. When we go from 2002 to 2014, for any given field, it's likely that that field is closer to the nearest ethanol refinery in 2014 than it was in 2002. That's not because the field has moved, but it's because new ethanol refineries are coming in on the map, right? And so we can see that here where I've got in the empty bars, distance to nearest ethanol refinery in 2002, we've got some fields that were 200 miles away. But by 2014, we see that there isn't really any field that's more than 100 miles away from that new ethanol refinery. And so this is going to give us variation in sort of proximity to this new kind of terminal market, and will let us say something about the effect of those refineries on local land use. This is the main result from this work, and you can compare this to that theoretical graph that I had from before. On average, we see that an agricultural field that's right by an ethanol refinery has a likelihood of about 33.5% of being grown to corn in any particular year. But once you're 30 miles away from that nearest ethanol refinery, that likelihood of being grown to corn goes down by about 1 percentage point. And it stays relatively flat after that. And so this sort of confirms the theoretical prediction that, for fields that are far away from these ethanol refineries, the location of the refinery doesn't have much of an impact on their cropping choices, but that there is a difference, between something that's 30 miles away or further and something that's close to one of these refineries. I'll skip over some of the rotational results that I've got because I would rather get to questions. If we aggregate this up by all the fields in our sample, what we can say is that between 2002 and 2014, across these 4 states, Nebraska, Iowa, Illinois, and Indiana, that we can attribute about 300,000 acres of corn that are being grown because of the placement of the ethanol refineries. So this is on top of any effect that, aggregate demand is changing prices for corn, and this is just thinking about those transportation costs. So you can look at this two different ways. So the one way you can look at this is to say there's this really precise local land use effect that we can attribute to the location of these ethanol refineries. Farmers are behaving economically optimally. There's a lot of sense here because on average, fields tend to be about 30 miles away from a grain elevator. So 30 miles seems to be a reasonable cutoff here. The other way you can look at this is 300,000 acres seems like a lot, but it's less than 1% of all the corn acres across these 4 states. And you might say that this is a relative drop in the bucket. So I talk about this research project mostly to help disentangle some of these local narratives from the aggregate narrative of what's happening with federal policy and highlight that there are trade-offs everywhere when we're thinking about crop rotation, crop choice, and the intended and unintended effects of federal energy policy. I'm happy to get into more detail about any of this, but I'd rather get us to questions, and I'll stop there, I think.
Thank you, Andrew. Thank you to all 4 of you. We do have a couple of questions that have come in for our participants. Feel free to keep adding those into the Q&A portion or into the chat if that is more familiar. We had a question around some opportunities for ethanol that comes from alternatives to corn. So looking at opportunities for adoption of perennial grasses like switchgrass and or other crops that have maybe less negative environmental impact. Is that something that any of you are able to speak on?
Well, I can say even here at University of Wisconsin, there's a research center, the Great Lakes Bioenergy Research Center, focusing just on this, trying to advance the technologies and the economics and the processing capabilities to enable kind of a more perennial cellulosic-based bioeconomy. So that would be like things like switchgrass. So I think there's definitely opportunity, and Geoff probably knows the economy much better, that they're just not at scale now or commercially available production. As far as kind of relating to that second question, I think sorghum can fit into the picture a little bit, and quite a few existing corn refineries could accept that as a feedstock with kind of minimal adaptation. So that might be an area that would be interesting. I'd be excited to kind of hear others' takes on kind of the interchangeability of feedstocks towards something that, in general, I've heard sorghum, a little less intensive than, say, corn, just on inputs and water use, things like that.
Yeah, I guess I could jump in here. I mean, you can make ethanol from anything that has starches and sugars and really any cellulosic and hemicellulosic material. It's just a matter of, can you do it economically and can you do it competitively with existing feedstocks and existing systems? And for the farmer, I mean, what they want to know is what's my net revenue per acre when they sit down to make their planning decisions. Every year, they want to know what is going to provide the best return to my farm, and currently that has been corn. So Tyler's right. There's been a tremendous amount of research and development over the past 20 years, 25 years, on using perennial grasses and other purpose-grown cellulosic feedstocks for ethanol. it's been tried. There have been a handful, probably half a dozen facilities that have been built to use those feedstocks. What they've found is there have been numerous handling challenges with this feedstock. There's been quality challenges with keeping the feedstock in condition, keeping it clean, transportation issues. So in order to make all that work, there's got to be a greater incentive for both the farmer and for the biofuel producer to switch from the current systems. And and that's been tried too. There have been numerous incentives and programs over the years. Some have come out of the Farm Bill, some have come out of DOE grant and loan programs, other USDA programs, BCAP, things like that. Higher RIN values under the RFS for cellulosic biofuels. So there have been opportunities. We just haven't been able to figure out how to make the economics work and compete in a way that is going to fundamentally change the market's behavior and current systems. But the other thing I would say is, just the premise of the question, I would invite you to go back and look at the environmental impacts of corn. We should not assume from the outset that corn is a bad feedstock for ethanol. When you do that full life cycle analysis, corn has proven itself as a tremendously efficient and sustainable feedstock for ethanol production. And it's improved over time. I mean, growing corn, as all the farmers on this call know, today is much different than it was 25, 30, 40 years ago. Tillage practices are different. Fertilization practices are different. The inputs are different. So, let's not be thinking about corn production through the lens of 2013 or, 2007 or even, earlier than that. Let's look at how things have evolved and where we are today.
A question related to kind of price for farmers, and as we want to see an increase in new and beginning farmers coming in, has there been research done on the effect of expanded corn production and higher prices of farmland?
Yeah, I mean, I think that's, some of the work that Andrew showed and that Tyler showed have, that research has suggested that the expansion of corn ethanol has resulted in higher corn prices. That shouldn't be a surprise. It's not a surprise to us. It's one of the reasons that farmers invested in building these ethanol facilities in the first place, was to add value to corn. They were producing corn and, it cost them $2.50 a bushel or $3 to produce the corn. And then they were selling it for $1.80 a bushel below the cost of production. Then they're going to USDA asking for assistance to keep them whole. So that dynamic was not sustainable. And so, yes, the emergence of corn ethanol has helped add value and raise the price of corn. That was part of the purpose. And as we've been discussing, we've been losing farmland, we've been losing cropland at an alarming rate over the last 50 years, even with the emergence of renewable fuels and demand from ethanol, that very likely would have accelerated that loss of cropland, would have accelerated more dramatically. Fewer farmers, fewer acres going into the crops that go into renewable fuels without that demand. So that, I guess, that'd be and yes, that all of that leads to higher land values, which, if you're a landowner, is a good thing.
I wanted to make sure that Andrew or Tyler, did you want to respond to that as well?
Andrew, this seems like it's up your alley.
Sure. I mean, like every good economist, I'm going to say, there's two sides of every issue, right? There's always another hand. So it's true that if any policy has an implication of raising temporary profitability for a thing, in the long run, that'll get capitalized into the value of a fixed asset. So landowners ultimately benefit if agriculture becomes more profitable in the long run. And so we think a lot about sort of how asset ownership has implications for long-term well-being of producers. Owner-operators versus tenant farmers have different long-run outcomes depending on that land ownership. the other thing I'll raise is someone's supply is someone else's demand kind of thing, right? Like high corn prices also mean high food prices. And so one person's solution to a problem is another person's new problem. So as we're thinking about what's the aggregate societal welfare of any particular policy, there are winners and there are losers to everything. There aren't Pareto improvements where everyone's better off. That's really just technological improvement. But how that technological improvement, lands on different actors in the economy is not always equal.
I think one of the questions that often comes up when talking about ethanol is around the efficiency of ethanol in the production itself. So a question around how much energy does it take to produce ethanol versus how much energy do we get from that ethanol?
Yeah, this is another one of those issues that has been another one of those myths that just doesn't seem to want to go away, and it's been studied over and over and over. And these are things that are measurable. These are you can go out and measure how much diesel fuel is used in a tractor during planting, how much fertilizer is used, and how much energy was used in the production of that fertilizer. You can measure all of the energy inputs into the corn ethanol process, how much natural gas is used at the ethanol plant. And there have been a number of studies that have done that. And, what they have found, at least in the last 5 to 10 years, is that there is no question that the energy return on investment for ethanol is positive, especially when you correctly credit the co-products, the distillers grains and the corn oil, and by a wide margin. Meaning if you put 1 BTU into the process to make corn ethanol, you're getting 3 or 4 BTUs worth of energy out the back of that process. We don't hear near as much about this kind of net energy debate as we did 10, 15 years ago. And I think that's because, for most people, it's been settled. The science is settled on this. But you do still see it in, comment sections under blog posts and things like that, coming from a place of just being, I think, misinformed or maybe uninformed on the issue.
I'll just jump in to agree with that, because knowing that Geoff and I maybe always don't agree on things, I think in the science in general shows the net energy return of ethanol is positive, and maybe what that margin is probably different, right? Geoff's probably got different numbers than others, but I think in general that is relatively in agreement across the scientific communities.
Thank you both. We have 2 questions about CO2 transfer. So the first part of this question is, I've heard about proposed pipelines for CO2 transfer from ethanol plants to North Dakota to be permanently sequestered in the earth, and what's driving that. And then there's also a second question around fuel tax incentives, and how that might affect both ethanol facilities and that pipeline.
Well, I'll start. I feel like I've been talking a lot, but I'll try to be brief here. I think those 2 questions are very much related. There are a number of new policies, both at the state level and at the federal level. Tax incentives under the Inflation Reduction Act, state policies like the low carbon fuel standard in California and Oregon that are either requiring or rewarding reductions in carbon intensity for fuels. And so for corn ethanol, one of the lowest cost and most effective ways of reducing carbon intensity is to take that CO2 that's released during fermentation that I mentioned, and rather than venting it to the atmosphere or capturing it for dry ice or beverage carbonation or whatever, putting it back in the ground and sequestering it permanently. If a facility is able to do that, they're able to cut their carbon intensity by 50% or more. So when I showed the slide saying average corn ethanol today is a 50% reduction versus gasoline, if that corn ethanol also had carbon sequestration and geological sequestration, now you're in the 75 to 80% reduction versus gasoline. ballpark. And again, what's driving that is the availability of tax incentives at the federal level, and state policies and international programs. To be honest, the Canadians have a low carbon fuel program in place. The Europeans have low carbon fuel programs that again either require or reward lower carbon intensity fuels, and so that's where carbon sequestration comes into play.
I'd just add on to get to that heart of the question too, a little piece of it, how might that change how corn is grown or where it's grown, things of that nature. I think kind of the universal takeaway, and that is probably universally agreed upon, if you're going to increase the incentives for that, you're probably going to increase the demand for corn, the prices received for corn, and the amount of corn grown. And again, that could be a really good thing depending on where you are. And if you're producing corn, it might have different impacts if you're on the other side of the equation and a beginning farmer trying to get access to land, or trying to rent out land for a forage for your dairy farm. Maybe slightly different impacts, but in general, probably those incentives are going to increase corn demand, increase corn prices, and increase corn on the ground.
I'm realizing that we're at 1 o'clock now, so we have a couple of additional questions that I'll stay on to ask if people have time. But I also wanted to make sure that I was able to give a couple of quick wrap-up notes. So first, if people do need to hop off, I really wanted to thank all 4 of you for joining us today and talking and answering some of our questions. I wanted to thank all of our participants who are on the call. We look forward and hope that you will join us at our Groundswell pre-convention as we continue this discussion and talk about ethanol production and corn production in Wisconsin and what that means for farmers. And so I'm going to be dropping a couple of links in the chat for folks. The links for our join as Wisconsin Farmers Union member and to register for convention if you are not already. And then if people are able to stand for a little bit longer, I do have a couple of additional questions. Okay, thank you. One more question that we have is there research on the effect of expanded corn production and higher prices? Oh, sorry, we asked that one. Next question. Is there a measurement that compares the cleaner burning fuel benefits to the cost of water quality?
I'm not aware of any analysis that would, weigh those two things. I mean, certainly we're aware of studies that have compared the water quality and water consumption impacts of various transportation fuels, various energy forms. But that's, I think, a different question than what's being asked. So I'm not aware of anything quite like that.
What was the question, Kirsten? It was the net economic benefit change in water quality versus.
Yeah, the measurement that compares cleaner burning fuel benefits to the cost of water quality from ethanol.
And maybe I know there's been some recent research looking at that looks at the water quality implications of the increased production and increased corn on the landscape, and probably looks at the economic implications of that, but I don't have a sense of the magnitude of those water quality costs relative to the air quality benefits.
Yeah. The only thing I'll add is, I mean, there is literature on each side of this, right? And so economists, when we try to estimate, sort of what's the health impact of cleaner water, or what's the health impact of, increased local air pollution from combustible engines or stuff like that, we end up quantifying some of those impacts in dollars, and that makes them comparable. But you're comparing these dollar impacts that operate through different pathways, right? So if for argument's sake, if the big downsides of burning fuels, whether they're ethanol or fossil fuels, is carbon emissions and local air pollution, that impacts us through a health channel. If water quality issues impact us through biodiversity loss or through reduced agricultural productivity, that's a different pathway. And so we can value both of those things in dollars, But it is challenging to sort of think of them as substitutes for each other.
And Kirsten, we can look around if we find anything. Happy to pass that on to you too.
Great, thanks. Yeah, I'd appreciate that. Maybe kind of final question. As part of our complex and nuanced discussion around ethanol and its impacts on farmers and rural communities and the environment, I know that one of the questions that will come up at our convention will be around, like, if we do want to transition away from more corn-based ethanol or just production in general, what are the resources or supports that are needed to help farmers transition in that? Because there are a lot of farmers in Wisconsin that are growing corn and across the Midwest, and how do we make sure that the resources are provided, or what are other incentives to help with different types of agriculture?
I would just say, I think Geoff covered some of them if we look at it from the cellulosic perspective. And NFE was very supportive of cellulosic ethanol, ethanol being made from any feedstock. We're supportive of all feedstocks and farmers' ability to be able to add value. And I think it just depends, and there's a lot of different government programs. I mean, Geoff hit on many of them that USDA operates, as well as a tax incentive for cellulosic, which is part of this Inflation Reduction Act that they may be the clean fuels tax credit that someone had mentioned in the question. So that's in limbo a little bit, but NFE, our policy and your policy is supportive of all that. So we'll try to gather some of those resources and give those to you.
Yeah, and the only thing I would, and I forgot to mention the $1.01 per gallon second generation biofuel producer credit, which does go to producers of cellulosic ethanol from cellulosic feedstock. Corn ethanol producers don't get that that incentive. But I would also, and I know NFU, I know Ann is doing this, but we expect there will be a new farm bill, or at least a discussion around a new farm bill next year. That's going to be the opportunity, we think, to really look at what programs are in place today, BCAP, and there are a lot of programs in the Farm Bill, and let's look at what has worked, what hasn't worked, and have a intentional conversation with the ag committees in both the House and Senate about about what policies might be necessary and what new approaches might be considered to look at expanding and diversifying the feedstocks that are being used for biofuels.
I guess what I'll throw in here, and the other word for economist is professional wet blanket, which is, I think when we try to use a policy to affect an outcome that's indirect, there are lots of unintended consequences of that policy. So the question asks, like, how do we support farmers during a transition, right? A policy that is targeted at supporting farmers that currently farm would look like direct payments to farmers. When we use different policies to try and have that impact by, supporting the market for a particular product, or for subsidizing an insurance product or something like that, there are unintended consequences of those policies and make them less efficient at the thing that you might want. That isn't to say that that's not what happens, right? We have a policy-making process that is making of sausage, and there are winners and losers for different things, but I'm always encountering these policies thinking about what's the intended impact and what's the unintended impact. And that trade-off is always there, and I think helpful to think about as an organization like the Wisconsin Farmers Union or the National Farmers Union develops, positions on emergency policy proposals.
And yeah, just brainstorming, thinking through to your question of, how do you better support farmers, producers who maybe want to transition away from that, or if policy shifted that we're trying to transition away from corn and ethanol. I think it's actually a pretty good time and a lot of opportunity with, especially like programs from the USDA, so conservation programs and funding that's available, support programs, as well as what I've seen really a shift maybe in those USDA programs towards a working lands approach. And so, being able to keep that land working and adding on practices that, kind of can increase the productivity of pasture lands or haying, even, discussions in the Conservation Reserve Program about, they've loosened up where it used to be just emergency haying and grazing, and now discussions of kind of using that to help transition to a working lands. And so if we think about Wisconsin in particular, where you've got, a lot of dairies and need for high quality forages and grazing and alfalfa, some of those types of transition programs to enable shifts into those forage crops or perennial systems seem like they're well supported right now, and there could be movement, and maybe something that the Farmers Union would, encourage in the policy, especially around Farm Bill, of like, yeah, can we boost some of those conservation programming, whether it's through the Inflation Reduction Act or through Farm Bill or the combination thereof. I've heard of, proposals of like allowing stacking of programs, so equip with others to kind of help layer on those and really support farmers where they need it in transitioning towards some of these perennial systems, things like that.
Thank you. Thank you all. I need to share the screen one last time from our facilitators for convention. I think we'll end here. And again, a big thank you for all of you for taking the time today to answer some questions and share with us. So thank you. I hope everyone has a great rest of your day.